Module Overview. Materials are the soul of sculptural practice. In this module, we undertake a comprehensive, cross-disciplinary, and technologically up-to-date study of sculptural materials, natural, synthetic, traditional, experimental, and digital, as well as the criteria and rationale for their selection. We explore the chemical, physical, structural, and expressive properties of these materials, and we dive deep into their processing, treatment, and application in different styles and contexts. This module also highlights the environmental, economic, and cultural implications of material choices, while evaluating how innovations in science, industry, and digital technology have expanded the boundaries of what is sculpturally possible. The artist's relationship with material is not passive, it is dialogic, manipulative, and often philosophical. As such, understanding materials in sculpture is both a technical discipline and an aesthetic conversation. Learning objectives. By the end of this module, you should be able to identify and classify the full spectrum of materials used in sculpture across eras and movements, understand the mechanical, aesthetic, and ecological properties of different sculptural media, analyze the suitability of materials for particular concepts, environments, or structural demands, apply knowledge of material manipulation techniques in traditional and digital practices, consider the historical, cultural, and ethical implications of material sourcing and use, experiment with hybrid and non-traditional materials in contemporary sculpture, critique sculptural works with an understanding of the material language being employed. Traditional sculptural materials. These materials have deep roots in the history of sculpture and continue to serve as fundamental mediums. Stone types: marble, limestone, granite, basalt, alabaster. Properties: hardness, permanence, resistance to weathering. Techniques: carving, direct and indirect, polishing, chiseling. Symbolism: strength, purity, monumentality. Limitations: heavy, labor-intensive, expensive, brittle when thin. Wood types: oak, mahogany, teak, pine, ebony, iroko. Properties: organic, flexible, warm-toned, responsive to tools. Techniques: whittling, chiseling, turning, laminating, burning. Cultural usage: African masks, oceanic totems, medieval reliefs. Limitations: susceptible to rot, pests, humidity, and fire. Clay types: earthenware, stoneware, porcelain, terracotta. Properties: malleable when wet, hard when fired, receptive to texture. Techniques: hand modeling, coiling, slab building, wheel throwing. Historical relevance used in Mesopotamia, Greece, China, and Africa. Applications: ceramic sculpture, maquettes, mold making, metal types, bronze, steel, iron, aluminum, copper, brass. Properties: durable, castable, weldable, recyclable, structural. Techniques: casting, lost wax, sand, forging, welding, chasing, patination. Symbolism: power, durability, modernity. Issues: high cost, requires technical skill and facilities, ivory, bone, and shell. Traditional in indigenous, religious, and ceremonial arts. Ethical implications today due to conservation laws. Modern and industrial materials. With the Industrial Revolution and modernist movements came new materials and aesthetics. Plaster used for molds, casts, quick models, installation components. Advantages: cheap, fast-drying, texturally versatile. Cautions: brittle if not reinforced, non-permanent. Resins and plastics. Types: polyester resin, epoxy, acrylics, PVC. Properties: lightweight, moldable, can mimic glass or metal. Used in conceptual sculpture, industrial prototyping, installations. Concerns: toxicity during curing, environmental sustainability. Found objects, assemblage, recontextualized everyday items, embraced by Duchamp, Nevelson, and contemporary artists. Challenges traditional material hierarchies and craftsmanship ideals. Experimental and hybrid materials. Contemporary sculpture increasingly crosses disciplines. Organic/biomaterials, soil, fungi, living plants, beeswax, blood, hair, skin. Reflect eco-consciousness, fragility, decay, life cycles. Examples: art using mycelium, bioresins, and biodegradable packaging. Fabric and soft sculpture materials, textiles, felt, leather, latex, thread, yarn, associated with feminist art, domestic symbolism, body and identity. Artists Eva Hesse, Klaus Oldenburg, Faith Ringgold, light and kinetic elements, neon tubes, fiber optics, moving components, motors, add interactivity, time, and sensory engagement to 3D forms. Digital and virtual materials. As technology redefines physical space, artists now sculpt in and through code. 3D modeling and printing software. Blender, Rhino, ZBrush, Fusion 360. Materials, PLA, ABS, resins, nylon, metal powders. Benefits, precision, reproducibility, automation. Augmented reality, AR, and virtual reality. VR, no physical material, only data-based spatial forms. Challenges materiality itself, often paired with real-world anchors. Philosophical impact. What is material in the age of the metaverse? Criteria for selecting materials. Sculptors weigh numerous factors when selecting materials. Criterion description. Conceptual relevance. Does the material embody the message? Durability indoors versus outdoors. Permanence versus impermanence. Aesthetics, color, texture, reflectivity, transparency. Workability tools and skills required, learning curve, cost and availability, budgetary and geographic considerations, cultural or ethical, meaning appropriateness, symbolism, environmental impact. Material preparation and treatment. Stone, roughing, chiseling, polishing, sealing. Wood, drying, sanding, varnishing, insect proofing. Metal, smelting, pouring, welding, grinding, patinating. Clay, wedging, modeling, drying, firing, glazing. Plastics, casting, cutting, sanding, curing. Sustainability and ethics in material use. Environmental costs of mining, quarrying, or deforestation. Use of non-toxic and biodegradable materials. Advocacy for ethical sourcing and post-use recycling. Sculptors as ecological stewards and cultural critics. Conclusion. To sculpt is to think materially. Mastery in sculpture demands not only formal skill, but a nuanced understanding of the physical, symbolic, and social dimensions of materials. Whether working with marble or code, bone or light, the contemporary sculptor is both artisan and philosopher, interrogating the world through form, texture, and substance.